Any preference? 15, 16, 17, 18 on page 143. Today's the 10th. So 15 through 18, 143. As I mentioned, I just got your written work. You will get partial credit. I will look at it, and by Monday, you'll have the grade in Canvas. Anything 70 and above is a very good grade. I'm very happy. Yes, Kirsten?
Does it matter if it's organized?
If I can read it, you have to sit next to me to translate it.
Okay, because I didn't be oh, no one.
You have to.
Okay.
Just remember that.
Sure how it should be.
Oh, but you have to be as organized as possible because you're showing it to somebody who has no idea where, right?
Yeah.
So please be careful next time.
Could we do number 16?
Yes, of course. Yes. Okay. Karen invested some money at 9%. I'm taking notes right now, right?
Right.
So I read the problem, I take notes, then I may have to read it again and then come back to my notes. So she invested some money at 9%, simple interest, annual simple interest, and 250 more. How do I write that? 250 more than what she invested at 9.
Just 250, right?
250 more.
Plus, like parenthesis, whatever the amount is, minus X or something.
So I invest X with Chris's bank, and I invest $240 more at your bank.
Plus 240.
Was it 240 or 250? 250. Okay. Then that amount at 10%. So right now I don't write equations just yet, right? I'm just taking notes, and then we read it again. If her total yearly interest was 101, $101, how much was invested at each rate? Now I read the problem one more time. I look again at my notes and see if they make sense. Karen invested some money at 9% annual interest, annual simple interest, and 250 more than that amount at 10%. So far, so good? If her total yearly interest was 101, how much was invested at each rate? Any questions? Valentine's candy.
Oh, thank you.
Valentine's candy. Everyone else. Okay, so how many equations and how many variables we have?
We have one equation.
One equation because I have how many variables?
One.
Exactly. So I deposit some amount of money at 9%, and then the same amount plus 250 at a different bank, and then exactly 12 months later, I go to the bank and I only say, well, just give me how much my money earned. Don't give me the deposit. Just give me only what I earned. And to the second bank, give me what I earned, and I count it as 101. So, can anyone help with the equation?
101 equals 0.9x.
Careful.
0.09x.
Oh, yeah, that's right.
So minus.
Plus 0.010. 250. I usually multiply 0.1 by 2.
We have parentheses.
Thank you.
Multiplying X plus 250.
Exactly, because this is what we deposited at the second bank. We did not deposit 250, right? Very good. Do we understand this equation? Everyone? Okay, now please dictate the first step. Yes. 0.09x plus 0.1x plus 25 equals 101. Do we agree with this step? Is it acceptable?
Yes.
Then, what do you recommend?
Combine like terms.
Perfect. Yes. Combine like terms, simplify the left-hand side, and I get point,
19.
yes, x equals, and I move 25 to the other side because it's a linear equation, and we know in linear equations we have to separate the terms with x from the terms without x. So what now?
You got 76 on the other side. So you track 25.
Very good. And x equals?
Would be 400.
How much?
400.
We'll check in a minute. Measurement unit? We don't trust anything. Measurement unit, what is 400?
Move that.
Meters, seconds?
Dollars.
Of course. Thank you. So now I go back and check. So let's put in the calculator. I want to show you how we do this. I know you know. So here it is. I have 0.09 multiplied by 400 plus 0.1. Obviously, 400 plus 250 is 650. I don't have to perform that with a calculator. And when I click enter, what should I get? What was the interest?
101.
Yes. If I don't get 101, something is wrong, correct?
Right.
So, therefore, Karen deposited 400 at the first bank and 650 at the other. Better? Is this okay?
Yeah, that's fine.
Good. Good. Other questions? Is there anything else you would like to see before we look at chapter 3?
I have a question.
Yes.
For me,
She needs a second to look at it. So, yes.
I was kind of confused with the implementation scale. I just don't know how to write it.
Give me an example.
So if you have x is less than or greater to,
I'm sorry?
if you have like x is less than or like equal to x, like I mean 12. I just don't know how to like do the brackets and the parentheses.
Okay, where on the real line, where is 12? Here, here, left of 0, right of 0.
Right.
Yes. So let's say this is 12. Let's read this. Which side do I look at? Which side of 12? Sorry. So which side of 12 will this be? To the left or to the right?
Left.
Yes, because these are numbers less than 12. Negative infinity to 12. You're representing this here. And that's the interval.
So if it was greater than, would you put the infinity on the right side?
But if it's greater than, then this is 12. Where will I go? Which side?
On the right?
For x greater than 12. Which side?
Made that way.
Yes, to the right-hand side, correct? Since it doesn't have the equal symbol, I have to put a parenthesis. I have to read from left to right. I cannot say infinity to 12 because we read from left to right. So I have 12, comma, infinity. Exactly what the interval is telling me, what the inequality is telling me. Better? So always write from left to right. Even in nations who write from right to left, like a Muslim and Israeli, they write from right to left. Math is still from left to right. Okay, anything else?
That graph for this one?
Is it chapter 3?
Yes.
Awesome. Very good. Yes.
I cannot. I tried to solve it, but
So the bar graph at the right shows the top 10 tourist destinations and the number of tourists that visit each country per year. Which countries shown have more than 60 million tourists per year? So 60 million. This, and this.
that's
So country A, B, C, D, and F. You draw a horizontal line and everything.
becomes
Yeah. Select all countries. Very good. So the problem was this. It was giving us a bar graph. So something like this for A, something like this for B, something like this for C, something like this for D, for E, and so on and so forth. So here we had 60. And if you draw a horizontal line at 60, you will see this country, this, and this have more than 60 whatever million people. And normally on the bar graphs, they put the numbers at the top. I haven't paid attention whether they are here. So they may write 100 here, they may write 50 here, 61 here, 80 here, and 85 here. Sometimes. If they don't write those numbers, then if you're asked to find which of these countries have more than 60 million people, I'm just making things up, you draw a horizontal line and see which ones are above that line. This one is not above the line. So in this case, A, B, C, and E have more than such and such. Is that okay? Good. Other questions for me before we look at chapter 3? Other questions? Other questions? Okay, so let's look at chapter 3. Chapter 3 is a very important chapter. It will teach us a lot of things about lines, reading from the graphs, graphing. So the title of chapter 3 is graphing. Okay, so that was a perfect example that we just looked at on how to read from the graph. Let's start by plotting points. So that's a quick review. Let's make up some points. Let's say 3, 2, let's say 0, 0, let's say -2, -4, let's say 0, 7, and 0, -3, and -4, 0. So we want to plot these points on a coordinate system. How will I plot them? So for 3, 2, 3 for x, 2 for y, 1, 2, 3, 1, 2. That is 3, 2. 3 for x, 2 for y. We remember this? Yes? Is that a yes? Is that a no?
Yes.
Okay. Now the origin obviously is 0, 0. So one more time, this is 3, 2, and this is 0, 0. That's done. -2, -4. We go to the left. X is -2. And y is -4. So this is -2, -4. -2 for x, -4 for y. 0, 7 is 0 for x and 7 for y. 2, 3, 4, 5, 6, 7, right here. This is 0 for x, 7 for y. Any questions so far? Any questions? Okay, 0 comma negative 3 obviously is 0 for x, negative 3 for y.
So the left side is the x and the right side is the y?
X is on the x-axis, y is on the y-axis.
Yeah.
X gives us the position, y gives us the height, the altitude. Good. Now, look at these 2 points that we have, 3 points, forgive me. Look at these 3 points that we have on the y-axis. Is there any conclusion that we can draw about any point on the y-axis?
X would have to be 0.
Awesome. That's the reason why the equation of this line is x equals 0. Okay? It's a vertical line at x equals 0. So imagine that I'm here standing at 0. If I move 1 step to your left, what equation am I?
-1.
Equation.
Oh.
You're right. But just say
X minus 1.
x equals.
Equal 1.
One more time. So this is x equals 0. I move 1 step to your left. What equation is this?
X equals negative.
Correct. I move 2 more steps to your left. What equation is this now?
X equals -3.
Perfect. Now I'm back to 0. I'm moving 2 steps to your right. What equation is this? X equals 2. Is that clear? Any vertical line is a position. X equals blah, blah, blah. Okay? Clear? So make yourself a note. This is very important. X equals 0 is the equation of the what?
Y-axis.
Thank you very much. So now we know this for forever. This is extremely important. Okay, so I'm back to my last point here. -4, 0. -4, 2, 3, 4. I don't go up and down because y is 0, so this is the point -4, 0. Please make up another point for me here. Any point you want.
-7, 0.
If this is -4, this cannot be -7.
Positive
Yes?
7,
Yes?
0.
Very good. That is perfect. So now, can anyone conclude? I have 3 points on this line. Can anyone conclude what is the equation of this line? Again, it's super important.
Y equals 0.
Right, it's the altitude. Now, if I'm here and I go up 1, what equation will that be?
Y equals 1.
Perfect. I'm here at 0. I want to go down 2. What equation will that be?
Y equals -2.
Perfect. So the equation of this line is y equals 0. All points on that line will have y 0. Right? So now, y equals 0 is the equation of the,
X-axis.
thank you, is the equation of the x-axis. Super important. Very, very important. We want to clarify this now moving forward so we don't have to address it again. Make yourself a note, a little notebook, new stuff, new information, new terminology, whatever you need to review, please. Very good. Let's suppose now I'm given an equation. Let's say I'm on page 182. And I would like you to pick any problem from 49 to 60. If you have your book. If not, I will pick. Okay, 54. We're not on a marathon, we're on a sprint here in this class. So y equals 1/3 x. Here's the question. Complete the table of ordered pairs for each linear equation. I kind of disagree with the vertical table because the x-axis is horizontal, not vertical. But I'm going to copy what they have here. So we have a vertical table here in which we are given 0, 6, I'm sorry, -6 and -1. How do I determine what is missing here? This is my equation. Y equals 1/3 x. How do I determine y if I'm given x equals 0? Yes, please.
Plug the numbers in with x.
Of course. Very good. Perfect, Nicole. So I plug in 0. So how much is 1/3 times 0?
0.
Awesome. Now I plug in -6. You have to imagine 1/3 multiplied by -6 over 1.
That'd be -2.
You will always simplify. Very good. Now I'm given y and I'm asked to determine x. So I plug in y now. I replace y by -1. -1 equals 1/3 x.
-3.
Yes. How will you solve this equation? Can anyone tell us what to do here? Other than Chris?
Divide both sides by 1/3.
Yes. Very good. However, the easiest thing to say is when you want to eliminate a fraction, you are multiplying both sides by the multiplicative inverse of the reciprocal. It's easier.
Right.
Because the division by 1/3 on this side will still have to, you'll still have to do that.
Right.
So it's easier if you say, okay, I know what I have to do. I'm going to, you can say divide by 1/3, which is perfect. I would rather say multiply by 3/1. So multiply by 3/1, multiply by 3/1. This is obviously what I want, which is 1. And the left-hand side is -3. I will always, of course, write it as x equals -3. Now, do we know what type of equation this is? Right, but what type of equation? Perfect. We only know one equation.
Linear equation.
It's linear, right? Good. So if it's linear, what do you think its graph will be?
A straight line.
A straight line. Either like this, or like this, or like this, or like this. 4 different types of lines. So this is one, this is the other, this is the third type, and this is the fourth type. What kind of slope, I'm jumping a little bit ahead, what kind of slope is this? Or if you want to say, what kind of trend is this? Positive, increasing, right? Positive. So this one will have a positive slope. Slope, positive. What about this one? We want a positive slope for our income, or what else? Happiness level, right? What kind of slope is this? Right. So when will we want a negative slope? Our debt to decrease. Personal debt, right? If somebody has high blood pressure, we want the trend for that high blood pressure to be decreasing or negative trend, right? Good. So there are a lot of applications. Slope less than 0. Okay, what about this? What type of line is this? In a second. So what type of line is it? If it's not a positive trend, if it's not a negative trend, and it's, which is, how do we call it? Very good. This is a horizontal line. What is the slope of this line?
0.
Yes. No slope is the other one. What type of line is this? Yes. The slope here does not exist.
Because you would have to do rock by 0 or something.
Excellent. Awesome. So that's another concept for your little notebook. 4 different types of lines. One with a positive slope, one with a negative trend, one with a 0 slope, and the other one with undefined, or it does not exist slope. Perfect. I'm coming back to this line. I want to graph it. Graph y equals 1/3 x. I know it's a line. How many points do I need in order to graph a line?
2.
Exactly. Can I use 3? Of course. Can I use 4? Yes. Can I use 1?
No.
No. Through 1 point, look how many lines I can draw. Infinitely through 1 point. But how many lines can I draw through 2 points? Just 1. Okay? I already have 3 points. I'm going to use 2. I'm going to use these 2. Or this and this. It doesn't matter. So please tell me what to plot. So I have 0, 0. And I have -6, -2. -6, -2. I connect and extend the line. Always have to write the equation of the graph, line or otherwise, on the graph somewhere. I graphed y equals 1/3 x. Any questions? Any questions?
Is that all you have to graph on this one?
If it's a graph, you graph it. Yep. Yep. That's all we needed. Okay. I would like to look at 66 so we can continue. The hourly wage Y of an employee at a certain production company is given by Y equals 0.25x plus 9. What type of equation is this? Yes, but that's perfect. But what type is it? Linear, right? X and Y have power 1. No X in the or Y in the denominator, right? No products of variables. This is linear. Power is 1. Okay, perfect. Where X is the number of units produced by the employee in an hour. Complete the table. Finally, they are giving us a horizontal table. This is one that I prefer. 0, 1, 5, 10. Okay. So now they're asking us, I already started replacing it without asking you. I have to ask you first. Complete the table. When X is 0, how much is Y? Good. When X is 1, how much is Y?
9
Of course. When X is 5.
10
Very good. And when X is 10,
11.5.
I would like to do this with you with a graphing calculator for a moment. If you have your calculator, I would like you to plug in Y equals. Click on Y equals. What will I plug in? What is my Y equals?
9.
Say it again.
9.
Y equals. Right?
0.25 x plus 9.
Yes, here's your X right here, right next on the right-hand side of alpha. This key is the variable key. And plus 9. So I entered in Y equals 0.25 plus 9. Now I have to do this all the time because the software gets back to the default. You may not have to do this all the time, but I have to do it all the time. Second and table set, I have to change the independent variable to ask mode. And press enter. I think you already have it from last time into ask mode, correct?
How did you do that?
Okay,
Yeah.
with second and table set. second and table set. And only the independent variable has to be switched to independent, to the ask mode. If anyone needs a calculator, I have one. Okay, so then go back to second and table after you complete that. So now the calculator is asking me or waiting for me to plug in what? Right. So what will I plug in? Please give me the values we would like to plug in.
0, 1, 5, and 10.
That's it. So 0, enter. 1, enter. 5, enter. 10, enter. Chris, you need help?
Yeah. I don't know how you got to that screen.
Oh, because you have already a plug in here. So let's de-highlight that. I'm sorry. So with second and table set, okay, then second and table, and now plug in your numbers. Are you okay? Yes? Are we okay, everyone? Okay. And these are the numbers that that Corey gave us, right, with the calculator. I prefer this method instead of plugging in, right? So plug in, create the function, put the function y equals, and then in the table you plug in the numbers u. Now the problem is that if you don't put it in the ask mode, the calculator will not allow you to plug in the numbers you want. That's why the independent variable has to be in the ask mode. Good. Part B of this question. Find the number of units that an employee must produce each hour to earn an hourly wage of 12.25. So that is part A, this is part B. 12.25. So 12.25 per hour. How do I determine how many hours does this person have to work to get that? Say it again. What? What? Where? How? What? Indeed, this is the y value. So now we are given the y value, we want to determine the x value. Awesome. So 12.25 equals 0.25x plus 9. This I know how to solve. How do I do it? Say it again. Of course, I have to subtract 9 and then? Perfect. This is how we solve a linear equation. So 12.25 minus 9 is 3.25 equals 0.25x. Obviously, x must be 3.25 over 0.25. So how many hours?
13.
Very good. Any questions? Any questions? So our next step is about, let me see where I am with time here. Oh, I'm fine. Okay, so now let's take a look at graphing linear equations. There are two methods. I prefer one, but my Labs Plus will ask you for both. Okay, so graphing linear equations. This is 2.2. I'm sorry, 3.2, of course. Two methods. Two methods. One of them is good. I don't disagree with it. But you will never be able to use it for any other function. The other method is necessary and it works for all functions. So that's why I don't fancy using the slope. Graph using the slope and y-intercept. I didn't need a comma here. I don't fancy this one. It's good to be able to read from the graph. It's good to understand it. But the other method is what we need moving forward for any function in math. And that second method is graph using x and y intercepts. This is the method that is important. This one is useful, but I wouldn't consider it top. Okay. Can anyone create a linear equation for us that we will graph using both methods? Okay, I will. So let's say y equals 2x plus 4. I'm going to start with graphing using x and y intercepts. And you will see in a moment, and when I give you the second example, you will understand why it's so important to be able to find the x and y intercepts. And this is not as powerful as this one is. Okay, so I already know what the equations are. We just talked about it 20 minutes ago. So find x-intercept, and then finding y-intercept. So in order to find the x-intercept, what do I know about the x-axis? We wrote it as a big note, and we said, very, very important. Forgive me, I talked at the same time with you.
No, I said it's horizontal. Is it
Say it again?
horizontal?
Yes. So what do we know about the x-axis? Awesome. That's what we know about the x-axis. So y is 0. I'll come back to it in a minute. What do I know about finding the y-intercept? What do I know about this line?
X is 0.
Yes, perfect. Very good. It's a vertical line, so that's x equals 0. Very good. So now, let's look at this equation. Here's what I advise my students to do. Y is 0, so then this is 0. I'm moving 4 to the other side. When I move 4 to the other side, what happens with 4? Yes. So I have then negative 4 equals 2x. Can anyone give us x? Awesome. Do not combine this with this. You have to give me an ordered pair here. Please give me an ordered pair that we just determined. Nope.
-2, 0.
Right. Perfect. Good. Now I'm done with this. Now I want to find the y-intercept. Now x is 0. Now this term disappears. I put my finger on it. Because 2 times x, which is 0, is 0. How much is y? Exactly. So what is the ordered pair now that represents the y-intercept?
0 and 4.
Very good. Do I need anything else? No. So
Why is y 4?
x is 0, y equals 4. So negative 2 comma 0 is right here. 0 comma 4, 1, 2, 3, 4 is right here. Connect and extend the line. Y equals 2x plus 4. Now let's talk about the other method. Always remember to write the equation next to the graph, so you know what you graphed. So let's go back now. So this was finding the x and y intercepts. I'm going to copy the same equation, and I am going to use a different method, which is slope y-intercept method of graphing. I still have to find the y-intercept. However, This is typical for an equation that is called, you already told me, the the slope-intercept form. Y equals mx plus b. What does m represent? Yes, m is exactly what we call the slope. What is the slope? The steepness of the line. See, this is a very steep line. This is not as steep, right? This is very steep. This is not as steep in positive direction. Also, I can have the same thing in negative direction. This is very steep. This one is not as steep as the first one. Okay, so the slope is, by definition, rise over run. The difference in y values over the difference in x values for 2 points. So for example, if I have this line, and let's say I have this point and I have this point, I have 2 points that lie on this line, and I want to find the slope of this line. Here's how I do it. I'm going to denote this point, it's my first point, x1, the first coordinate x, y1, the first coordinate for y, because it's my first point. How do you think I am going to denote the second point? Right, because it's my second point, right? So x2 comma y2. In order to determine the steepness of this line, using these 2 points, I have to find how high I go from one point to another vertically, and how much horizontally I go from one point to the other. So this will be the rise, walking from here, how many feet I go up, meters or whatever you want, how many, this is the rise between the height of this point and the height of this point. That would be the rise from point 1 to point 2. What will be the run? How much distance I cover horizontally. You can say, but you're going up on the hill. True. But I have 2 pieces of information that change. One is the position, vertical position. I'm moving from here. So there is a change in x. And also I'm moving vertically, so there is a change in y. And that will give me the slope, or the steepness of the line. So the rise is from where I arrive minus where I started. So then the rise will be y2 minus y1. This height minus this height is, this difference is how much I went up vertically. And what do you think will be the run? x2 minus x1. The second position where I arrive minus the first position where I started. Good. So then let's compare these 2 equations. X is x, y is y. How much is m? Exactly. M must be 2. Now I'm going to talk about b. So the slope is 2. What is b? How much? And I'll explain what b is. 4. Very good. Always with the sign in front. If this were -4, then I would have said b is -4. Good. So let me explain b. So for this line, m equals 2. Oops. So m equals 2. But actually, m is a ratio. Rise over 1. I didn't want to say that. Rise over run. So then 2 is the same with?
2 over 1.
Right. What does this mean? It means that this line has a positive slope or a negative slope. I know it's silly. Does it go up as has a increasing trend, or does it go down as a decreasing trend? Up, right? Because it's positive. Good. So if we walk on this line, how much do we go up and at the same time to the left? Say it again. Right. So we go up 2, the rise is 2. Meanwhile, we'll go horizontally 1. Up 2, horizontally 1. So that's what it means. So up 2, horizontally 1. Okay. Now what does this B represent? Yes, B is the y-intercept, always to be understood as an ordered pair. Always. What ordered pair? If it's a y-intercept, what do I know about? Which coordinate? I know for sure it has to have if it's a y-intercept.
X is 0.
Right, because I know that the equation of the y-axis is, the equation of the y-axis is x equals 0. Awesome. So then what is the y-intercept?
4.
As an ordered pair, always.
0 squared.
Very good.
Oh, yeah.
Okay, so now, this is my starting point. Remember what I'm doing. I'm trying to graph using the slope and the y-intercept. I have to start with the y-intercept. I have to plot the y-intercept first, and then I have to use the slope to find the second point. So, 0, 4. 1, 2, 3, 4. That's the bottom point. I go up. One more time. How much I go up?
2.
2. How much do I go to the right?
1.
1, 2, and 1. Up 2, horizontally right 1. Should have written here. Okay. However, I'm having difficulties here. This is a crucial point, and I don't know where it is because I didn't determine it. I use this method that is not as powerful as the previous one. Doesn't give me this. I have no idea what this is, where it is. But still, I graphed a line, the same line, 2x plus 4. The reason why I present it is because MATLAB Plus will ask you to do this. I will personally never ask you to do this. Now, here's another example. Let's say 2x equals 3y plus 6. If you want to graph this equation using slope-intercept, or using the slope, I should say, you have to divide by 3. And that makes it a little bit more difficult, right? Because if I have to divide by 3, I will have 2/3 as the slope. I'm not saying it's impossible. I'm saying 2/3 is slightly more difficult than 2/1. Now, what if I use the x and y intercepts? What do I get then? Let's check. So for the x-intercept and for the y-intercept. In order to determine the x-intercept, what do I have to do? Yes, very good. I have to set y equal to 0. Okay, it's gone. I cover it. How much is x?
3.
Very good. So now, see, I don't have to solve for anything if I use x and y intercepts. Which ordered pair did I just determine?
3 and 0.
Awesome. How do I determine the y-intercept? Very good. Here it is. I cover it. I move 6 to the other side. What happens when I move 6 to the other side to solve for y? Yes. 6 goes to the other side, becomes negative. So I have 3y, and y equals? You already told me. -2. I need the ordered pair.
Zero and -2.
Very good. That's all I need. If I use the slope, I have to divide by 3. I have to identify the slope. I have to find the y-intercept. And I have to go up 2, left 3, blah, blah, blah. So not only that is, I think it's a little bit more difficult, but it's not as useful as this one is moving forward. There is no other function but the linear function that you can graph using the slope. This will never happen again in your math life or adventure, only for the linear function. So then why bother? It's useful somewhat because I can read the slope. So if I have a graph, I can read the slope. But if I don't have the graph, then, and I have to graph it using the slope, for this equation, it's slightly more difficult. Okay, so I'm going to plot the points we just determined. 3, 0. Here it is. 1, 2, 3. 0, -2. And connect and extend, and I'm done. Write y. I'm sorry, 2x equals 3y plus 6. This is the equation that we just graphed. Any questions for me?